Hey guys, we're going to look at power of a power, property of exponents. So power of a power, so we have a to the m, all of that raised to the nth power would equal a to the m times n. All right, so let's look at what does this mean, right? Again, you can find this on your star chart. There it is, power of a power. There it is. Again, it doesn't help us though if we don't know what it means, right? Okay, so in this case, remember we have exponents are base and then the exponent. In this equation, this expression, this whole thing a to the m is actually our base, right? So now it's like this expanded story, you know, when people like kind of stretch it, make it bigger than life, right? This is that story. So now instead of just it being 3 to x, now we're saying, oh, hey, I have 3 squared, and then that to another power. Okay, that's what this means. These are two separate powers. So I take this term and I'm raising it to this, and it says, oh, if I'm doing that, I can multiply them. Okay, so let's look at what does this really mean. All right, so if we have 2 cubed to the second power, right? This 2 to the third, that whole thing is our base this time. Okay, that tells us, remember, exponent tells you to multiply the base times itself that many times. So this tells me take 2 to the third, because that's my whole base, times itself twice. So that's where we get this, 2 to the third times 2 to the third. Okay, and if we wanted to go even further, then we could see like, hey, 1 2 to the third is 2 times 2 times 2. The second 2 to the third is 2 times 2 times 2. And what we've already looked at, 1, 2, 3, 4, 5, 6. We have our 6 here. But remember, our rule said I can multiply these powers. Well, let's test it. If I do 3 times 2, there's 6. Woohoo! So that's the proof of why it works. Remember, you can always start expanding things if you need to see it for yourself. All right, so let's try this. So our first example, A, is x squared to the third power. Okay, let's go with the expansion first. Let's just prove it. So x squared is our base. This is the base. And this is how many times to multiply it times itself, right? So x squared times itself 3 times. All right, we know that now this is all multiplication. So now I can add those powers. So this should be 2 plus 2 plus 2 is 6, right? And if we do this, x to the 2 times 3, right, is 6. This equals this. All right, so this should equal x to the 6th, right? There's our proof expanded. That's what it would equal if we use the product of powers rule. There's my proof that it works with the power of powers rule. All right, so here we go. Let's expand it one more time. We have y to the 5th times z to the second power. Okay, this is our whole base right now, that whole thing, right? So I'm going to have y to the 5th times z times, we're doing it twice, y to the 5th times z. Okay, now we can use our product rule. I have same base here, so y, so I should end up with y, and that's 5 plus 5, so I should have y to the 10th, and then I have z, and I have 1, 2 of those, so z squared. Here is the multiplication proof, right? So if I were to look at this, y to the 5th times z squared. Remember, if I can't see the exponent, it's still there, it's just a 1. So this is the same as saying y to the 5 times 2, right? So I'm going to multiply 2, then I'm going to multiply it times z's exponent. So z to the 1 times 2, 5 times 2 is 10, 1 times 2 is 2. Woohoo! All right, you feeling it? All right, let's try it with this division right here. Okay, so h times a squared divided by p squared to the 4th. Okay, I'm going to expand it just because I want you to see this with division really quick. So I'm taking that whole inner term. This whole thing is my base right now, okay? And it says multiply that times itself 4 times, right? Because I want you to see why the rule works, okay? So I have this and its multiplication on top, and it's all multiplication in the denominator. They're separated by division, okay? But I can multiply across the numerator, I can multiply across the denominator. So this would give me how many h's? I have 1, 2, 3, 4. So h to the 4th multiplied times itself 4 times. I have a squared, so 2, and then another 2, 4, 2, 6, 2, 8. So a to the 8th over p, and I have 2 plus 2 plus 2 plus 2. So p to the 8th, right? Okay, remember, so that's what it should be. If I went back here to the original, I'm just going to erase on mine real quick so you can see it a little better. Okay, if I went back to the original, we have 4 times 1 is the 4 for the h. 4 times 2 gives us 8 on a, and then 4 times 2 gives us 8 for the p. Okay, so it still works with division. You just multiply it times all the exponents. Okay, so here we go. We have m to the 3rd, k to the 4th, h squared times n to the 3rd, all raised to the 6th power. Okay, so we're going to go straight into our rule. So it would be m to the 3rd times 6, k to the 4th times 6, h squared times 6, n to the 3rd times 6, right? So we're taking 6 times all of our numbers, all of our exponents inside. All right, so then this would give me, I'm going to start it over here because that box looks a little small. So I'm going to have m to the 18th. I have k to the 24th, h to the 12th, and n to the 18th. Okay, so that is my final simplification. Okay, let's do it again. All of this to the 7th power, so we just go one by one. A to the 3rd, multiply it times the power. B to the 1st, if you don't see it, it's 1 times 7. C to the 6th times 7. D squared times 7. E to the 5th times 7. Whew, lots of it, but here we go. 8, and then 3 times 7 is 21. And then we have b to the 1 times 7 is 7. C to the 6 times 7 is 42. D to the 2 times 7 is 14. And E to the 5 times 7 is 35. Whew, big numbers, don't be afraid. Okay, all right, last one is our fraction. Remember, you were still exact same rule. Okay, times all the exponents. So we're going to have k to the 2 times 5, a to the 1 times 5, and r to the 3 times 5, all over e to the 2 times 5, and n to the 1 times 5. Okay, so when I simplify it, I'm going to end up with k to the 10th, a to the 5th, r to the 15th, all over e to the 10th, n to the 5th. Okay, there's our simplification. And now your final step would be go in the calculator. You're going to substitute in, type the original, see what it is, type your simplified one, see if they're the same. Okay, and do that each time just to verify we didn't do some funky mistake that we should need to correct. But that is the power of powers rule. Try it.